Welcome to Senior High School General Mathematics, Module 3, Week 4. Lesson 1 of this module is all about one-to-one functions. The objective of this is that at the end of the lesson, the learner will be able to represent real-life situations using one-to-one, illustrate one-to-one functions, identify one-to-one functions, and illustrate horizontal line test. For our activity 1, identify whether each relation represents a function or not. Number 1, we have there sets of ordered pairs 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our x values are 1, 3, 5, 7, and 9. As what have you observed, there are no two the same x values, so our answer in number 1 is a function. Number 2, another set of ordered pairs, we have 3, 2, 2, 4, 1, 6, 5, 3, 6, 3. Again, our x values are 3, 2, 1, 5, 6. No the same x values. So our answer again is, it is a function. Number 3, another set of ordered pairs. We have there 2, 2, 4, 4, 3, 2, 3, 7, 1, 4. Our x values are 2, 4, 3, 3, 1. We have there the same x values, which is 3, so it is not a function. For number 4, evaluate the function at x is equal to 3. We have there the given f is equal to 5x plus 3. So again, f is equal to 5x plus 3. That will become f is equal to 5 times 3 plus 3. So we substitute the value of x, which is equal to 3. Next, f is equal to 5 times 3, that is 15, copy plus 3. So 15 plus 3, that is equal to 18. For number 5, evaluate the function at x is equal to 3. So we have there the given, g is equal to 2x minus 1 divided by x plus 2. That will become g is equal to 2 times 3 minus 1 divided by 3 plus 2. So we substitute the value of x, which is equal to 3. Next, 2 times 3, that is equal to 6, copy minus 1, and then 3 plus 2, that is equal to 5. So we have there g is equal to 6 minus 1 divided by 5. Next, 6 minus 1 is equal to 5. So we have there the numerator 5 and then copy the denominator, which is also 5. And then 5 divided by 5, that is equal to 1. Our final answer is g is equal to 1. Activity 2. Identify whether the given situation represents one-to-one function. Number 1, the relation pairing the LRN to students. LRN is a unique learner's reference number of a student. No two learners have the same LRN. So, this is a one-to-one function. Next number, the relation pairing a real number to its square. So for example, we have a real number 2. Its square is 4. Another real number is negative 2. Its square also is 4. So negative 2 and 2 have the same square, which is 4. That's why this is not a one-to-one function. Number 3 given is a set of ordered pairs. We have there pairs 3, 1, 4, 2, 3, 2, 1, 2, and 5, 4. As what have you observed, 3, 1 and 3, 2 have the same x values, and 4, 2, 3, 2, and 1, 2 have the same y values. So, number 3 is not a one-to-one function. Number 4, we have set of ordered pairs 2, 2, 4, 4, 3, 2, 5, 7, and 1, 4. Pairs 4, 4, and 1, 4 have the same y values. Again, this is not a one-to-one function. Number 5, another set of ordered pairs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No repetition on the x and y values, so number 5 is a one-to-one function. The function is a one-to-one function. The function is one-to-one if for any x sub 1 and x sub 2 in the domain of f, then f of x sub 1 is not equal to f of x sub 2. That is, the same y value is never paired with two different x values. Next, we have here the ways to determine whether a graph represents a one-to-one function. We have the horizontal line test and the vertical line test. I will show you graphs, and what you're going to do is to identify if it is a one-to-one function or not. The first graph is the graph of y is equal to x cubed. The broken line there is the horizontal line test. The horizontal line touches the graph at only one point. So, it is a one-to-one function. The next graph is a graph of y is equal to x squared plus 2. As what have you seen, the graph touches the horizontal line at 2 points. This graph is not a one-to-one function. What's more? Activity 3. Which of the following relation is a one-to-one function? For letter A, we have their set of ordered pairs 0, 0, 1, 1, 2, 8, 3, 27, 4, 64. X values are 0, 1, 2, 3, and 4. Y values are 0, 1, 8, 27, 64. No repetition on the X values and Y values, so letter A is a one-to-one function. Letter B, set of ordered pairs. We have here negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. X values are negative 2, negative 1, 0, 1, 2. Y values are 4, 1, 0, 1, 4. So as what have you seen there, we have repetitions on the Y values which are 1 and 4. So letter B is not a one-to-one function. C. Set of ordered pairs are 0, 4, 1, 5, 2, 6, 3, 7, and so on. So the value of x is n, and the value of y is n plus 4. So we have here one-to-one function. Letter D, height to student. This is not a function. Why? Because heights of students can be the same. Next, person to telephone number. This is a one-to-one function. F, height to age. So this is not a function since a height of a person when paired to its age can be the same to the height of another person of the same age also. Next, birth date of a family member. Again, this is not a one-to-one function since birth date of a family member can be the same. What we have learned? Number 1, what is a one-to-one function? The function is one-to-one if for any x sub 1, x sub 2 in the domain of f, then f of x sub 1 is not equal to f of x sub 2. Next, how to identify a one-to-one function? The same y value is never paired with two different x values. What is a horizontal line test? This is a test which is used to determine one-to-one function. What is a vertical line test? A test used to determine a graph of a function. How will we know that a given graph is a graph of a one-to-one function? Each horizontal line intersects the graph at most one point. Let's proceed to lesson 2, inverse of a one-to-one functions. At the end of the lesson, the learner will be able to illustrate the inverse of a one-to-one functions, solve the inverse of a one-to-one functions, state the properties of inverse functions. What's in? Activity 1. Identify whether the given situation represents one-to-one function or not. Number 1, SIM cards to cell phone numbers. Of course, that is a one-to-one function. Pairing of airports to airport code. Yes, that is another one-to-one function. Number 3, the function of f of x is equal to x squared. That is not a one-to-one function since x squared is a quadratic equation. Next, we have there the set of ordered pairs 1, 2, 1/2, 3, 1/3, 4, 1/4, 5, 1/5, 6. So as what have you observed there? There is no repetition on the x and y values, so this is a one-to-one function. For number 5, set of ordered pairs, we have their pairs 2, 1, 1, 3, 4, 8, 5, 7, 6, 9. The x and y values have no repetition, so it is a one-to-one function. Number 6, we have here graph. Now, if we are to test this in a horizontal line test, so the graph touches the horizontal line at exactly 2 points. So this means this graph is not a one-to-one function. Number 7, if we are to draw a horizontal line, the horizontal line touches the graph at only 1 point. So this is a one-to-one function. Activity 2, match the following one-to-one function to its inverse. We have here column A and column B. What do you think is the inverse of f of x is equal to 3x plus 1? The answer is letter D. Y is equal to x minus 1 divided by 3. How about the inverse of function number 2? G of x is equal to x cubed minus 2. What do you think is the answer? Yes, the answer is letter C. Y is equal to the cube root of the quantity of x plus 2. How about number 4? F of x is equal to 2x plus 1 divided by 3x minus 4. Its inverse is y is equal to 4x plus 1 divided by 3x minus 2. Number 4 has no inverse. As we go along with our lesson, we'll discuss why number 4 has no inverse. Let f be a one-to-one function with domain A and range B. The inverse of f, denoted by f of negative 1, is a function with a domain B and a range A, defined by f of negative 1 of y is equal to x if and only if f of x is equal to y for any y in B. Note, only one-to-one function has an inverse. Here are the steps in finding the inverse of a function. First, write the function in the form of y is equal to f of x. Next, interchange the x and the y variables. Last, solve for y in terms of x. Example number 1, find the inverse of f of x is equal to 3x plus 1. Again, our given is f of x is equal to 3x plus 1. We will write this in the form y is equal to f of x. So this will become y is equal to 3x plus 1. Next, we will interchange the x and y variables. This will become x is equal to 3y plus 1. And then we will solve for y in terms of x. So, x minus 1 is equal to 3y. And then to solve for y, we divide it to the x minus 1. So, the inverse of f of x is equal to x minus 1 divided by 3. Example number 2. Find the inverse of g of x is equal to x cubed minus 2. Again, our given is g of x is equal to x cubed minus 2. We will write this in the form y is equal to f of x. So we have y is equal to x cubed minus 2. Then, interchange the variables x and y. So we will solve for y in terms of x. So we have x plus 2 is equal to y cubed. And then we have here, the cube root of x plus 2 is equal to y. The inverse of this function is the cube root of x plus 2. Example number 3, find the inverse of f of x is equal to 2x plus 1 divided by 3x minus 4. We will write this in the form of y is equal to f of x. This will become y is equal to 2x plus 1 divided by 3x minus 4. Next, we will interchange the variables x and y. So we have here x is equal to 2y plus 1 divided by 3y minus 4. We will multiply x by 3y minus 4 and then copy 2y plus 1. X times 3y, that is 3xy, and x times negative 4, that is negative 4x. Just copy again 2y plus 1. We will combine in one side those terms with variable y. So we have here 3xy minus 2y is equal to 4x plus 1. And then we will factor 3xy minus 2y y times the quantity of 3x minus 2 is equal to 4x plus 1. Y is equal to 4x plus 1 divided by 3x minus 2. So this is now the inverse of the function 2x plus 1 divided by 3x minus 4. Now this is the reason why item number 4 is no inverse function. Because in item number 4, the given function y is equal to x squared plus 4x minus 2 is not a one-to-one since it is a quadratic function and the graph is a parabola that opens upward. It implies that this function fails the horizontal line test, thus it has no inverse because it will touch the graph or the horizontal line at 2 points. Properties of an inverse of a one-to-one function. Given a one-to-one function f of x and its inverse, then the following are true. What's more? Activity 3. Apply the steps in solving the inverse of a one-to-one function. Number 1. F of x is equal to 1/3 x plus 1. So we will write this in the form of y is equal to f of x. So that will become y is equal to 1/3 x plus 1. And then interchange the variables x and y. That is, x is equal to 1/3 y plus 1. Then solve for the value of y. X minus 1 is equal to 1/3 y. And then 3 times x, the quantity of x minus 1 is equal to y. So 3 times the quantity of x minus 1, or that is 3x minus 3. So we have here now the inverse of the function is 3x minus 3. Number 2. Find the inverse of f of x is equal to 2x minus 1. So we will write this in the form y is equal to f of x. So that is y is equal to 2x minus 1. Next, interchange the variables x and y. That will become x is equal to 2y minus 1. And then solve for the value of y. That is 2y minus 1 is equal to x. And then 2y is equal to x plus 1. Y is equal to x plus 1 divided by 2. This is now our inverse. Number 3. G of x is equal to 3x minus 1 divided by 2x plus 3. So again, we will write this in the form y is equal to f of x. So we have y is equal to 3x minus 1 divided by 2x plus 3. And then we will interchange the variables x and y. We have x is equal to 3y minus 1 divided by 2y plus 3. Next, solve for the value of y. So we have here 2x times the quantity of 2y plus 3 is equal to 3y minus 1. So x times 2y, that is 2xy, and x times 3, that is 3x. Just copy 3y minus 1. Next, combine on one side the terms with y variable. So we have 2xy minus 3y is equal to negative 3x minus 1. Then we will factor 2xy minus 3y. So we have here y times the quantity of 2x minus 3. Copy negative 3x minus 1. Next, y is equal to negative 3x minus 1 is equal to 2x minus 3. This is now the inverse of the function. What is the inverse of a function? The inverse of f, denoted by f inverse, is a function with a domain B and a range A defined by f inverse is equal to x if and only if f of x is equal to y for any y. How to identify an inverse of a one-to-one function? By following the 3 steps. See, what are the steps in solving the inverse of a function? First one is, write the function in the form y is equal to f of x. Next, interchange the x and y variables. Lastly, we have solve for y in terms of x. Number 4, state the properties of an inverse function. We have here the properties of the inverse function. Let's proceed to lesson 3, graphs of an inverse function. The learner will be able to represent an inverse function through its table of values and graph. Find the domain and range of an inverse function and solve problems involved. Activity 1. Make a table of values representing the following function when x ranges from -2 to 3. Draw the graph. Number 1 given, we have y is equal to x plus 3. Number 2, f of x is equal to 2x plus 1. And number 3, f of x is equal to 1 divided by x. Y is equal to x plus 3. So we have here the table of values, x, and then we have here y. So x ranges from -2 to 3. So we have -2, -1, 0, 1, 2, 3. If x is -2, what will be the value of y? So we will solve that if the value of x is -2. So copy y is equal to x plus 3 and then substitute the value of x, which is equal to -2. That will become y is equal to -2 plus 3. -2 plus 3 is equal to 1. So when x is equal to -2, y is equal to 1. Next, if x is equal to -1, what will be the value of y? So we will copy again the equation, y is equal to x plus 3, and then substitute the value of x, which is -1. This will become y is equal to -1 plus 3, and -1 plus 3 is equal to 2. So if x is equal to -1, y is equal to 2. If x is 0, what will be the value of y? Copy, y is equal to x plus 3. Again, substitute the value of x, which is equal to 0. So this will become 0 plus 3. And 0 plus 3 is equal to 3. So if x is 0, y is 3. If x is equal to 1, what do you think is the value of y? So we will copy again the equation, x is equal to x plus 3. Then substitute the value of x, which is 1. Y is equal to 1 plus 3, and 1 plus 3 is equal to 4. So if x is equal to 1, y is... If x is equal to 2, what do you think is the value of y? Again, we will copy the equation, y is equal to x plus 3, and then substitute the value of x, which is 2. So 2 plus 3 is equal to 5. If x is equal to 2, y is equal to... If x is equal to 3, so we have the equation y is equal to x plus 3. Substitute the value of x, which is equal to 3. 3 plus 3 is... And that is equal to 6. So if x is equal to 3, y is equal to 6. The graph of y is equal to x plus 3. So we have here already the table of values, and we will plot this in the graph. So if x is, we have here the ordered pairs x, -2, y, 1. So -2, 1 is here, -1, 2 is here, 0, 3, 1, 4, 2, 5, 3, 6, and then we will connect it using a line. So this is the graph of y is equal to x plus 3. We have here example number 2. F of x is equal to 2x plus 1. Again, our table of values. So we have here the values of x, which ranges from -2 to 3. So we have -2, -1, 0, 1, 2, and 3. Now if x is equal to -2, what will be the value of y? So we will copy the equation and then substitute the value of x, which is -2. So that will become x is equal to 2 times -2 plus 1. 2 times -2, that is equal to -4 plus 1. 1. Negative 4 plus 1 is negative 3. So if x is negative 2, then y is equal to negative 3. If x is equal to negative 1, so again copy the equation, substitute the value of x, which is negative 1. So that will become 2 times negative 1 plus 1. 2 times negative 1, that is equal to negative 2. And then copy plus 1. Negative 2 plus 1, that is negative 1. So if x is equal to negative 1, y is also equal to negative 1. If x is equal to 0, what will be the value of y? So copy, f of x is equal to 2x plus 1. Then substitute the value of x, which is 0. So that will become 2 times 0 plus 1. So 2 times 0, that is equal to 0. Copy plus 1. 0 plus 1, that is equal to 1. So if x is 0, then y is equal to 1. What will be the value of y if x is equal to 1? So copy. Function f of x is equal to 2x plus 1. Substitute the value of x, which is equal to 1. That will become 2 times 1 plus 1. 2 times 1 is equal to 2. And then copy plus 1. 2 plus 1 is equal to 3. So if x is equal to 1, then y is equal to 3. When x is equal to 2, what is the value of y? So we have here, f of x is equal to 2x plus 1. Substitute the value of x, which is equal to 2. The function is 2 times 2 plus 1. So 2 times 2 is equal to 4. Copy plus 1. And then 4 plus 1 is equal to 5. So if x is equal to 2, then y is equal to 5. If x is equal to 3, then the value of y is what? To solve that, we will copy f of x is equal to 2x plus 1 and then substitute the value of x, which is equal to 3. So that will become 2 times 3 plus 1. 2 times 3 is equal to 6, copy plus 1, and then 6 plus 1 is equal to 7. So if x is equal to 3, then y is equal to 7. We will now plot the graph of the function of f of x is equal to 2x plus 1 in a Cartesian coordinate plane. So we have there the pair negative 2 and negative 3, negative 1, negative 1, 0, 1, 1, 3, 2, 5, and 3, 7. We will connect that using a line. So this is now the graph of f of x is equal to 2x plus 1. Number 3, f of x is equal to 1 divided by x. So we have here the values of x, which ranges from negative 2 to positive 3. So we have the x values, negative 2, negative 1, 0, 1, 2, 3. If x is equal to negative 2, then what will be the value of y? In order to solve that, we will copy first the function f of x is equal to 1 divided by x. And then substitute the value of x, which is equal to negative 2. This will become 1 divided by negative 2. Now, if x is equal to negative 2, the value of y is equal to negative 1/2. When x is equal to negative 1, what is the value of y? So again, copy the function f of x is equal to 1 over x, and then substitute the value of x, which is equal to negative 1. So this will become 1 divided by negative 1. 1 divided by negative 1 is equal to negative 1. So if x is equal to negative 1, then y is equal to negative 1. What is the value of y if x is 0? F of x is equal to 1 divided by 0. Always remember that division by 0 is not possible. So 1 divided by 0, it is undefined. This time, what will be the value of y if x is equal to 1? So again, we will copy the function f of x is equal to 1 divided by x, and then substitute the value of x, which is 1. So this will become 1 divided by 1, and 1 divided by 1 is equal to 1. So if x is equal to 1, then y is equal to 1. Next, x is equal to 2. So we will copy the function f of x is equal to 1 divided by x, and then substitute the value of x, which is equal to 2. So this will become 1 divided by 2. If x is equal to 2, then y is equal to 1/2. X is equal to 3. F of x is equal to 1 over x. If x is equal to 3, then 1 divided by x will become 1 divided by 3. So if x is equal to 3, then y is equal to 1/3. We will plot the graph of f of x is equal to 2x plus 1 in a Cartesian coordinate plane. So we have here the ordered pair, -2, -1/2, -1, -1, 1, 1, 2, 1/2, 3, 1/3. Given the graph of a one-to-one function, the graph of its inverse can be obtained by reflecting the graph about the line y is equal to x. The domain and the range of the inverse function can be determined by inspection of the graph. We have here the example of the graph. F of x is equal to 2x plus 1, and its inverse x minus 1 divided by 2. Another, we have here the inverse of x cubed minus 1, and the graph of the cube root of x plus 1.